yourself and then, or should we proceed? You have raised hand, so I don't know. So we'll take it at the end. If I hope technically there is no difficulty.
No sir, you please continue. Raise hand will be taken care after the webinar.
Right. Thank you. Okay. So as he says, we'll take those questions later. So I have defined what classification and regression means. So regression means you are predicting the continuous value, and classification means you are predicting the class. So those classification classes may be binary, maybe more classes depending upon the situation. So these classification problems are such as predicting email spam or not. So who sends your email into a spam folder suddenly? It's a machine learning problem where you're classifying an email comes automatically, it goes to spam, it goes to ham. So like it goes to inbox. So this is classification. Credit approval is classification. Students letter grade is classification. So if there are more than 2 grades, then it's not just binary problem, but it may be multi-level problem. Okay, so this is what the supervised learning process is. So how do we then handle a problem? If I assume that this concept of a supervised learning problem is clear, we have the data in hand. The data is divided into 2 categories. One is our output, another one is our input. Input may be more than 1, output may be more than 1. Normally we take 1 as output variable, but let it be multiple. There's no problem. So what we are talking about, just repeating it, suppose I have the data with me and I am sitting at a manager's place in a bank and I need to decide whether to approve loan or not. So for that, the problem is clear. I need to just decide whether to approve loan or not. So this becomes response variable, 1, 0 category, and input variables could be any of these variables, such as you have person's age, marital status, where is he staying in urban area or rural area, how much he is earning, and so on and so forth. So all these become input, and then this becomes output. 0 and 1 becomes output. So how do we address the issue? So what we do, the data when it comes to us, we divide it into 2 components. You might have heard about it. I mean, some of you are already aware of this, but just study that data is divided into 2 parts: testing and training category. So we have there are several rules for this. How do we divide the data? You can just search on it. So training data is to train the model. Testing data is to actually find out the accuracy. Training data is known to me. So I know X, I know Y, I know weight, I know height. So training data is like using the height and weight which are known to me to train a model. Once a model is built, then the model is not built just to test the given data, but the model is built because I want to see when the next application comes, I will put these values from the input variables and will get an output variable. So for that reason, before we apply it, we go for the test data. Test data is also named as unseen data. Unseen data is like the training data is not trained on that data, but it is for testing data. So accuracy is always measured by using the test data, and model is trained by using the training data. So what is accuracy? So for classification purpose, it is very simple. Logically, you can define it. How many number of classes you are correctly classifying divided by total number of classes, total number of instances. So that becomes your accuracy. For the purpose of classification. For the purpose of regression, we can define in terms of error. I defined it. I'll talk about it later. This is what the algorithm is. So you are starting with training data, learning the algorithm. This is those who are from electrical, they might be knowing about this your linear, non-linear kind of systems where you're just putting a function. So that function is your learning algorithm. This may be linear, this may be non-linear. So training data is put in your algorithm, and then you get a model. Now you test that model on the test data and state the accuracy. Once you check the accuracy, if the accuracy is not as per your expectation, you go back and change the model, and then accordingly you can work on this. Performance measure, as I talked about it, there are 3 things: repeating, experience is what your data is, task is what the problem you have in hand. So clearly identify. See, data will not, a lot of people come to us bringing the data. Sir, I have got this data from Kaggle. Just tell me what to do with this data. There's nothing which you can do with the data. If you do not have the clearly identified task, the data is nothing but the garbage. You have a lot of data put on different websites. So unless you define the task, so these three things are equally important. None of them is less important than other. One is experience, the data. Second is what is the task in hand, what is the problem, and third is what is the performance measure. All three are equally important. So before defining any task, before identifying the data for that particular task, you need to make yourself clear that you have these three things very clear in your mind. Okay, so what performance measure is like this accuracy measure, number of correct classification divided by total number of classes. Similarly, we have performance measure for regression problem, where we just define it as how much are you getting from your predictive model, and how much is the actual values. That difference is what defines us. So this is a logical definition, nothing to do with with mathematics. So actually, if you look at it, this is again a logical way of defining it. Actually, it might be positive, it might be negative. Positive and negative are just two classes. So actually, the patient may not be as serious that you need to send him in ICU. Actually, the patient may be as serious that you may need to send him in ICU. So actually, there may be positive or negative chances. And what you are predicting is positive or negative. Just to give a real example, suppose there is a patient going to hospital, he may be corona positive or negative. Now, suppose he is positive, and the doctor gives a test, and that test also predicts him positive. Then it is fantastic result. If he was actually positive, doctor is also saying positive, so it is true positive. Fantastic. If he was positive, doctor says negative, then it is false result. If he was negative, doctor says positive, then again there is a problem. If he is negative, doctor also says negative, then there is no problem. So if you look at this matrix, this is called confusion matrix. It's a very important matrix. The diagonal entries, these diagonal entries are the actual accurate value. Positive, predicted positive, negative, predicted negative. Where is the problem? The problem is here and here. Those who read statistics, if you look at your testing of hypothesis, there is something called as type 1 error and type 2 error. So which is very, very similar to this situation. So what is the accuracy? If I define from here, what is the accuracy? So accuracy is actually total number of predictions, and that total number of prediction, if we take into denominator and numerator should be these positive, true positive and true negative value, then that becomes the level of accuracy. So that's how the accuracy is defined. Okay, so I have written over here true negative, true positive divided by total number of which are classified. So that becomes the accuracy. It's not a great measure. You can easily define it. So can be seen easily. One more thing before we apply any model to the real data. There's something called as no free lunch theorem. What does it mean? It means that there is no model which can be called as best model. A lot of people come and ask, so which model is nowadays very good in the market among those machine learning models? No model is good. Every model has some value to it. Or other way, I would say, no model is very good. Every model is good. So that means what? That means you try out many different algorithms before you declare it as your model. So those algorithms may be, when you talk about classification, there may be several different algorithms. When you talk about regression, there may be several different algorithms. You try out all those algorithms and see the accuracy level. When the accuracy is matching with your expectation, then you call it as the best model. So that's what it is. The no free lunch theorem says no model can be claimed as the best model. I'll give examples from these three areas. Although it could be like several different algorithms we can talk about, and we can talk at length because machine learning is a subject in itself. So I'll give a very simple problem of simple linear regression. Why I'm giving these problems? If you go and relate it with your real life scenario, you can generate some data and you can test this. So for example, if you talk about, let's say, height and weight, height और weight का एक model बनाना है, तो very simple task. Go and collect some data. कुछ लोगों से height पूछ लो, उनका weight पूछ लो, write down those data and then fit a linear regression model. That's how you can build a model. Very simple analysis. So going to simple linear regression, although some of you may be knowing, but bear with me for some other people. So simple regression, what is simple regression? So simple stands for two variables, one versus one. So I have one input, one output. Height, weight, height. Yesterday's stock price, today's stock price. And let me tell you, this is very, very important. Even in market today, those who are connected to market, those who know about the beta of a stock, this beta comes from this simple regression. So a very simple analysis, but very important. So simple regression is like going for one model prediction from another, going for one variable from another variable. So if it is assumed to be linear, then it is simple linear regression. So these are technical terminologies. You have y is equal to a plus bx plus epsilon. So here this a plus bx is what linearity stands for. So you have linear relation between x and y, and this will not be exact. Therefore, there will be some error, and this error is what is called as random error. Because the data is random, x and y are random values, so therefore there will be this error, and this error is random. So what is this error all about? Error is actually, as we talked earlier, when we talk about regression, what is the error? Error means what is the actual value and what is your predicted value. The difference between the two is error. So this is your actual value y, and this is the predicted value. A plus bx is what we are calling as predicted value. What you are expecting for y for a given value of x. So therefore, this y minus y hat is your predicted value, y is actual value, and the difference is what is called as error. What are a and b? So x is your input variable, y is your output variable. How do you get it? So define it. You take the data of height, you take the data of weight, declare one as input variable. If you are interested in getting weight based on height, then height is declared as an input variable. Weight is declared as an output variable. By the way, this model is not reversible. You cannot think like mathematically. If you obtain a relation between y and x, then revert it and it works like x and y. No, it doesn't work like that. The error term will be very different from between, if you take it as dependent variable, this error term will be completely different when you take this as a dependent variable. So you have to declare all these things upfront. So this y minus y. Now, what are a and b? So a and b are arbitrary parameters which you need to find out. So what is linear regression? Y hat is equal to a plus bx. Y hat is your predicted value, and predicted value can be predicted by using a plus bx. X is the given input. A and b, these two things you have to find out. How do you find out? So finding it out is like, again, a logical question. This is your error. So I would simply say that, minimize this error or choose values of a and b so that this error is minimum. Now, how do you choose? So somebody may say, okay, this is a very simple algorithm. I'll start with a is equal to 1, b is equal to 0. You can start with any one. So you start with a is equal to some value, b is equal to some value, and then look at the error. And then again, start with some other value and look at the error. Similarly, when you look at this, and you can claim whenever you get the minimum error. So that logical algorithm. But we cannot go like this because we have several data. So in machine learning, we use what is called as gradient descent algorithm. In simple statistics, we use what is called as least square approximation. Although they're same, final result will be same, but that's the principle behind it. A and B will be chosen such that this epsilon, the error term, is minimum. And because the epsilon we cannot talk about, the region is when you sum over epsilon, it will become 0. So we talk about epsilon square, positive error sum of squares. And this is very important quantity. Not only for this regression, telling you only two things you have in place. One is this sum of squares error, and second is your confusion matrix. If you can understand these two things, your third component, which is performance measure, will be very clear. Okay, so accordingly we call it as least square and so on and so forth. So I'm not going into details of this, but just giving an example over here. So by the way, asking the organizers, how much time is left for me? Hello?
Sir, you may go ahead. There is no time limit.
नहीं limit to define कर देते. Okay, so maybe I'll take 15-20 minutes and then we'll have questions. Is that okay?
Yeah, generally it is declared as 1 hour webinar, but
Alright.
if you want to take it 15 minutes, there is no problem with that.
All right. Thank you. Yeah. If you look at this entire phenomena, you'll be able to understand. Finally, if you look at this, I am starting from here and I need to reach to this destination. Earlier algorithms were like, I'm starting from here. I have decided that this particular path I'll choose and I'll reach over here. Now, what you're doing in ANN, you're saying, no, I'll not just start from here and will reach over here. I'll start